So hello everyone, my name is Alice Frémand and I am a geophysics data manager at the UK Polar Data Centre. So you have already heard about the UK Polar Data Centre from my colleague Mary. So I won't give too much details on what the UK Polar Data Centre is, but today I will present on Bedmap3, a data management perspective. So Bedmap3 is a collaborative community project that has been endorsed by SCAR, the Scientific Committee on Antarctic Research. And the main output is a new map of Antarctic ice thickness and bed topography for the international glaciology and geophysical community. So it represents more than 60 years of data, 82 million points, 277 surveys, and more than 80 collaborators worldwide. The previous version of Bedmap3, called Bedmap2, had already 1,500 citation and is used worldwide by climate scientists. So as I said, Bedmap3, the main output is a map of ice thickness, but how do we know how thick the ice is? So most of the measurements have been made using an aircraft. So you have an example on the image here. So this aircraft has been specifically modified to measure radio echo sounding data. So under each wings, you have antennas and they will send radio echo sounding waves that will be reflected back. And we will measure the time for the wave to come back and its intensity. And what we will get is a radargram. So this is the image that you have on your right. And so you will have different information from these images. So the dot line in red is the surface of the ice, and in blue is where the bed is. So, and this is this information that we will extract from this radargram. So somebody will just pick where the bed and the surface is, and by doing the subtraction between where the surface and the bed is, we will get the ice thickness. So within Bedmap3, we do have also ground-based radar echo sounding data, gravity, and seismic data. And the data were acquired since the 1960s in Antarctica. So the Bedmap3 was the third iteration. So after Bedmap1, which was published in 2001, Bedmap2, which was published in 2013, and finally Bedmap3 in 2025. And on these maps, you can see the different coverage that has been added each time at each iteration. And between Bedmap2 and Bedmap3, we added 52 million points, and this is the two-thirds of everything. So that gives a total coverage that is in the blue map. And there are still gaps, but with the addition of all these points, we were able to increase the resolution of the map to have a resolution of 500 by 500 meters. Since the beginning of Bedmap3, data management was really at the core of the project. And this time we decided to not only publish the map, but also all the underlying data. So the points that people have picked manually most of the time will be also published alongside. So Bedmap3 consists of different types of data sets. So we have the data points, so exactly the extraction of what was extracted from the radargram. So where the bed and surface elevation and ice thickness were at the, like this is at the scale and the resolution of each survey. And then we have also summarized points. So this is where we put the information in the 500 meter by 500 meter boxes. And then we have the gridded products where we did an interpolation to make a beautiful map. So the data points. So these are underlying data, but they refers to the ice thickness, bed, and surface elevation data that are used in the interpolation. And the include all possible data collected over the last 60 years with minimum quality checks. So all non-value data were converted to -9999. Minimum and maximum values are in reasonable range, and each point needs to have, at a minimum, information about ice thickness, bed, or surface topography. And I emphasize here that this does not mean that the data points have been used in the final products. It's really giving all the points that have been picked, but there might be errors. So it's important to understand that. So then for these data points, we try to make them all the same. So you need to understand that it was more than 80 collaborators with the same data, but none of the data were the same. It was not always the same order, or it was not the same unit. So we had to make a way to make all this data the same. And we had a lot of conversation with the researchers, and we discovered that we wanted an easy format. So something you can open in an Excel spreadsheet or something easy for them. So that's why we decided to publish the data in a CSV, but we customize it with integrated header information for better reviews. And so this is what you have here. And so at the top of the CSV, we embedded some information. And so each metadata starts with a dash, and then you have like a field with its information. And we developed at the PDC some codes that will automatically read that and will be able to interpret it. And so that means that the data are machine readable, and then we use some standardization for each variables, so using the CF convention, and we link to other resources and processing information. Because it's coming from a lot of organization, some of the data might have already been published somewhere else, but we did lots of standardization. So in this example, for example, we did have the source and the DOI of the resource that was used. So now let's talk about the summarized points. So the summarized point are statistically summarized points centered on a continent-wide 500 meter per 500 meter grid, and that reports the average values of the full resolution survey data plus information on their distribution. So you have summary statistics that can be used by researchers to assess the confidence in the average data. So that include minimum and maximum information of ice thickness or bed information or surface elevation. So we published everything at the UK Polar Data Center, with each having a specific DOI. So if you want a list of data and metadata, you can use a QR code. We use open format, so the CSV for the data points and the summarized point are geo packages and or available as well as shape files. And we used ISO 19115 metadata, so the ISO 19139 implementation. So in addition, so we develop also some Jupyter notebook for the user to more easily interact with the data. So you have the list of all the data available, also how to download the data, both manually and programmatically. And then you have also a way like Python code that shows how the summarized points were calculated, for example, and so you can do it on your own as well. And you have like different codes to help you interact with the data and open the data. We have also a data portal. So from there, like you can also interact with the data, look at the coverage of each survey from the different iteration of Bedmap, and look at also the data from the different providers. Then you can, for example, have you zoom in, and so then you can click on each point, and that will have information about the summarized information. So here you can see all the statistics regarding one summarized point. And then so you can interact with the map, but also you have access to tools. So you can measure distances. So if, for example, if you want to plan a new survey, it can be quite useful to zoom in or to look at an area you want to survey again, or if you want to have a look at more specific information, you can also have calculate areas and things like that. And obviously, you can download the data. So then the final project is a map. This is how it looks like. And so some fun facts. Yeah, the thickest ice in Antarctica is from Bedmap3 is in the weakest land and is at 4,757 meters, with a mean ice thickness over Antarctica of approximately 2,000 meters. The highest point is Mount Vinson at 4,892 meters, and the deepest bed point is the Denman Glacier of minus 3,500 meters. Yeah, so you can learn more with the associated publications. So we have a paper that look more at the data side of things and more the data points and the summarized data. And it does have a lot of information regarding our extended CSV if you want to know more about this. And then the scientific paper is more regarding the gridded data. Finally, some lessons learned in future data management projects. So while at the beginning of the project, data management was seen as a side requirement for many, engagement with scientists highly improved with the development of tools they can use for their own purposes. And now they ask for data management advices for an associated SCAR project with other geophysical data. So for example, I've been in communication with the Architecture and the Rings project. And so it benefits, it really showed the benefits of data management by scientists and standard reuse as part of other projects. Yeah, so I think that's all. Thank you.
Alice, thank you very much. That was a fascinating talk. I know we certainly use Bedmap3 as an example to our researchers as the power of what can happen when you share your data. So yeah, it's a fantastic
it's
project.
really how we use data as well to make a compilation project.
Yeah. We've got time for a question or two.
Thank you for a very interesting presentation. How fast are the changes, especially in ice thickness, over time? And if they are fast, can you then still put all the ice thickness data from different periods in the same map, in the same combined map?
So that's a very difficult question. So I have a few information. So in fact, the oldest the information is, in fact, it's more the horizontal location that is more problem than the vertical uncertainty. So, for example, in the 60s, there were no GPS, and so the location of a point, in fact, can be really wrong, and so that adds a lot of uncertainty. As of the last questions, so I'm not an expert on this, so I was really the data manager. So if you want, I can give you the contact of the people who really did the compilation. But as a note, so in future step, we will, because Bedmap1 was the oldest version, and it was quite difficult to discriminate between surveys, but now I've done it. So it will be published quite soon. And so within the new publication, there will be information about the GPS information. So what type of, at least, location instruments, or if it was dead recording, or if it was the GPS, or what type of like how the location was measured at the time, and will be provided.